Selecting an industrial gear motor frame is not just a catalog match. The frame affects how torque is delivered, how the unit fits into the machine, how service teams reach the drive, and how much redesign risk appears after procurement has already moved forward. A frame size influences the housing layout, shaft diameter, flange dimensions, and motor compatibility. These details decide whether the gear motor can sit cleanly inside an existing machine space or whether the surrounding structure needs extra adjustment. When those fit points are ignored, a technically capable unit can still create installation delays and avoidable cost. Torque capacity is a central part of the decision. A larger frame can support higher torque demand, but the physical size also changes weight, handling, and mounting requirements. The better choice is not automatically the biggest frame available. The better choice is the frame that supports the load while keeping the machine layout, service access, and installation process manageable. Power should be reviewed together with duty cycle and operating environment. A drive that looks acceptable under light use may behave differently in continuous work, frequent starts, or heavy loading. Heat, vibration, and surrounding equipment can all affect long-term reliability. For that reason, procurement teams should ask how the frame size supports stable operation under the actual working conditions, not only under ideal catalog conditions. Space is often the limiting factor. A compact machine may have narrow clearance around the motor, gearbox, coupling, guard, or support structure. A frame that fits the mounting face may still leave too little room for wiring, lubrication points, fasteners, inspection, or removal. Before purchase, the installation envelope should be checked from every service direction, including the path needed to lift or replace the unit. Weight also changes the maintenance plan. Larger gear motor frames can require stronger supports, clearer lifting points, and safer access for technicians. If the unit is difficult to remove, routine service becomes slower and downtime becomes harder to control. A practical specification should therefore include access, handling, and replacement considerations, not only torque and power. Maintenance needs are closely tied to application risk. Machines that run in demanding production areas need a frame choice that supports stable alignment and repeatable service. Shaft position, flange style, mounting rigidity, and compatibility with surrounding components all affect whether the drive remains reliable after installation. Small mismatches can turn into vibration, where overheating or repeated adjustment work. Supplier evidence matters as much as the specification. Drawings should confirm the real dimensions. Performance data should match the intended load. Support teams should be able to explain mounting options, motor compatibility, and service expectations. When possible, buyers should compare the proposed frame against the current machine drawings before approving the order. The strongest purchasing decision balances torque, power, space, and maintenance in the same review. A gear motor frame should fit the machine physically, support the duty requirement technically, and remain practical for the people who install and service it. When those checks are handled before purchase, the final selection is more likely to deliver stable operation without unnecessary redesign, downtime, or maintenance difficulty.